So you've got this diagram on the right and you've got this mass hanging down here, and it actually gets pulled up a certain amount from O. So if P starts here at this point where T is, and then you can see you need more string to get around here. So that extra bit of string has pulled this mass from 0 up to M. So we really want to find that how long that extra bit of string is. So we're comparing it to the first length here, which is at R. So that's when we start at 0. So how much longer than R is it? And if we look at that triangle APC there, you can see that we are given that this length from A to C is R plus R. So that's 2R from A to C. And then we're interested in this length here up to P, so PA. And then of course we know that PC is also R because it's the radius of the circle, and we're given that angle there. So if we want the distance PA or PA squared, we can use the cosine rule. So we've got AC squared, and so that's 2R squared, the other side squared, minus 2 lots of AB cos theta. Alright, so if we put that together, 2 squared is 4, and then we've got this fifth one, so we've got 5R squareds here. And here we've got 4R squared cos theta. We could factorise by the R squared, so we've got 5 minus 4 cos theta. So our PA would be R, square root of 5 minus 4 cos theta, because of course we want a positive length. Now that's P to A, so we want to find how much longer that is compared to R. So we know it's longer than R, but how much? So if we subtract R from it, we then know the difference between it and R. So they wanted the minus R at the front. All right, yeah. So that's how we get the length X, because that difference between R and what PA is how much extra string we needed. So it's that mass is being pulled up, that X distance. So this is the same as X equals there. And if you have a look at that, what is going to change here is, we know cos theta. If you draw cos theta like that, we know it's always going between -1 and 1. So at the highest it's 1, at the lowest it's -1. Now if I pop 1 into there for cos theta, I get 5 minus 4, which is 1. Square root of 1 is 1. 1 times R is R. So you end up with minus R plus R, which is 0. If I put -1 in there, I'm getting 5 minus minus 4. So that's 9. Square root of 9 is 3. And then we've got 3 R's. Here we'll have 3 R's minus an R. So we'll get 2 R's when we sub in cos theta equals -1. So you can see that the range of this X is going to be between, at the lowest 0, at the highest 2 R's. Alright, that's what it's going to range between. So it's going to start at 0, it's going to go up to 2R, then it's going to come back to 0 and back up to 2R and back to 0 and back up to 2R, etc. Alright, as this P goes around and around and around, that's what happens. Okay, so if we look at B, and I'm going to need a bit more room, so I'll just rub out what perhaps we don't need so much anymore. Whoops, we probably did need that. That's X there. Okay, so if we want to differentiate that, we want dx to theta, well, let's first write X in index form. So we've got -R plus 5 minus 4 cos theta to the power of 1/2. So if I want to find dx to theta, of course that -R goes to 0. So I have to use a chain rule, so this power of 1/2 comes down to the front, so I've actually got 1/2R, and then the bracket to the power of -1 would be -1/2 times, now go inside that bracket and differentiate, so minus 4 cos theta becomes 4 positive 4 sin theta. Okay, so if I were to write that nicely, I've got a 4 here divided by a 2 over here, so that's a 2, and the R's on top, and this sin theta is on top. So 2r sine theta all over, this will be negative power, so it's at the bottom, and power of a half, so it's square root 5 minus 4 cos theta there. And you can see then that if we're looking at, so that would be our velocity. And if we're interested in where our velocity, or our, where is it? Yeah. So where we're traveling upwards and where we're traveling downwards. So basically, where is this greater than 0? So where is this velocity greater than 0? And where is this velocity less than 0? Where is it going up in the positive direction? Where is it going down in the negative direction? And if you have a look at it, of course that bottom is under a square root, so it's got to be positive. So what I'm really looking at is the top. And on top you see we have a sine theta. So basically what we're saying here is, where is sine theta positive? And remember, we're going all the way around, so we're going from 0 to 2 pi. Now we know the sine curve goes like that. So we know it is positive between 0, so when theta is between 0 and pi, and we know it's negative, we know it's negative between that pi and the 2 pi. So for this bit here, it's negative. So it's going up when theta is 0 to pi, so as we go around this circle, the angle is 0 to pi. So as we're pulling further away, so it's heading up to the top of x there. And then as we come back, you see the string will get shorter and shorter now. It was getting longer before, now it's getting shorter, and then it goes back to the beginning. So that's when it's heading down there.